My name is Jack Holden, and with my mentor, Dr. Reza Ahmadzadeh, we work towards autonomous underwater inspection and cleaning. Our motivation for this project were that underwater tasks are difficult to complete. This is mainly because the underwater environment is uncertain and dynamic. There's a lot of things that can change very quickly and that you can't predict. Also, divers cannot go below a certain depth underwater, so if there's some tasks that they need to complete very far down, we need to think of an alternative to be able to solve those tasks. And also, the teleoperation of robots becomes challenging at certain depths because there's some input delay between the controller and the robot. So by the time the robot actually does the action that you're requesting it to do, the time has passed. And so our goal is to make underwater robots more autonomous by developing learning algorithms that can have them take in all the variables in their environment and perform actions in real time without human interaction. We focus on inspection and cleaning of underwater structures with this project. So our mission is 3D inspection of a sunken ship. So the first step is we travel to the site of the ship, and then we locate it within that site, and finally we inspect the ship. The method of coverage that we use is 3D structure coverage. We use an algorithm that simplifies complex 3D structures into 2.5-dimensional ones, so structures that just have flat edges on all sides. And then we create either a hemisphere or a cylinder model around these structures and then base the coverage path off that hemisphere or cylinder model. Here's a video of the simulation in action. So first the robot's traveling to the site of the ship and then locating it within that site and then orienting itself so it knows exactly where it is in the environment, traveling to the first point of the coverage path and then completing the coverage path while inspecting the ship. There was a previous simulation where the robot builds a model of the ship, and that is what this coverage path right here is based off of. In real life, we use the blue ROV2. We chose it because it's lightweight and affordable, and we did have to assemble it from scratch. So you can see here's the frame that we built, and then also the electronics enclosure with all the thrusters. And here is the almost final complete product, and then this is a picture of it completed. And there it includes a 360-degree sonar for inspection and a water jet for cleaning. Some further research that can be done based off this work is to consider the environmental factors that make this task challenging, such as if we put it into an environment like the ocean or a lake, we'd have to take into account the current because that could knock the robot off its course. And also, we could examine the cleaning dynamics further. This includes the coverage area of the water jet and whether we would need to take more time in certain areas or not. And so this is the presentation. I want to thank you for listening and also thank, again, my mentor, Dr. Reza Ahmadzadeh, and the UROC Immersive Scholars program for this opportunity.